Okay, I think it's time to go. Today I'm going to talk about how service evolves and over time, a number of users and what we should care about in terms of system and scaling security normatives to help your business, to help to the growth of your business. I'm Eric Cho. This is my name, written in Korean. I'm a software engineer. I'm working for Cisco now. I'm an entrepreneur. I worked for a number of startups as a developer and CTO. I'm a writer. I'm posting technical articles regularly, but mostly in Korean. I'm a translator. I worked on a Land of Lease book in the US that into Korean. These are important modules to early stage startup because they have to build all from scratch, and lack of resource and experience, they often do not know how to do it efficiently. So what I will talk about is what kind of problem exists and what solutions can you choose, and normative behaviors when it comes to security module. Let's think about the first state of your business. You will have your own laptop and one server somewhere. First thing you need to do is make a LAMP stack, and install some necessary service for your development task. Not sure whether you know, but scaling comes at a price and complexity. So you don't introduce them until it's warranted, until you've got many users and more issues. When your users reached at 1,000, you will have to have certain monitoring solution to not lose your customers' loyalty, right? I will cover them later in this presentation. Do you have a question? No? Oh, sorry. Likewise, backup is important just in case of you encounter some unexpected incident, right? This always comes with a solid recovery plan. Now we have 10,000 users. So from this moment, you need to prepare some situation while you maintain your production service stable and consistent. So if we have a slave server that replicated in a asynchronous manner in the background, then the replicated server can be used when master server has some failure. If you think that's a time to scale out the database, so distribute the query load equally, then we could think of this kind of architecture. So you can divide the write query and read query. The read query can be distributed among a number of slaves we have. So if you set up a proxy for the distribution, then we could, then you need to know, then you don't need to modify the client application code. Most of the times we use HA proxy, for example. If you accidentally deleted the record, let's just say that we deleted accidentally. So it may affect on normal users. That's a critical situation. For example, you probably forgot to type where statement while you are manipulating query statement. Then you need to restore the data from the backup, but it takes a lot of time. That's a problem. From a user's perspective, that will be a denial of service, right? If we keep some tables which has warm or cold data, but it's fairly small, then it could be easy. Let me bring my 2 cents here when it comes to database incidents. So first of all, you need to duplicate some specific tables to your secondary schema in MySQL Server. We can have multiple database. So then you will have to synchronize it periodically because it's not automatic in MySQL Server. If it's cold data, then you could add it to scheduler to synchronize 1 or 2 times per day, for example. A MySQL server can have multiple databases, as it normally be referred to schema in other database. It's a kind of namespace for tables in MySQL server. So if you have a duplicate schema, even if it's not 100% same, it will give you a relief for when you make a mistake like that. So when your users now reached at 100,000, it's time to have more machine to take your peak traffic. In many cases, it's not enough with vertical scaling from this moment. Adding more RAM, disk drive. Also, we need some mechanism for failover and redundancy for safety, right? I had to do something else here. Duplicated web app server and placed load balancer to distribute the traffic equally. Using the TLS is highly needed as the wire transmission is exposed to everyone else and is not safe, right? To limit access, placing servers behind VPN is recommended. So when you write code, there's a security checklist for startup that I made, so I will cover them later. There are two things I need to mention in terms of scaling. That is cache and queue. Cache is very efficient approach for recently viewed resource, especially when most traffic concentrated on specific points. For example, you sent push notification to millions of users. Then using the cache, we don't need to care some cost for recalculating, regenerating the heavy access resource. Queue is good for delegating large body of works asynchronously in the background. So by using it, your web server is able to delegate, taking off the slow chunks of code from your main request response cycle. So, so make the server cycle to be short. This is important point in server development. Otherwise, the delay for each request would be accumulated over time, and the responses would take more time. So your service will die eventually. Okay, let's assume that we've got 1 million finally. Then what's the number of millions stand for? Someone might not be interested with this number, but in 2004, Facebook has got 1 million users. It must be. It sounds to be very much amazing, right? But from my experience, when it comes to performance, it was horrible. Our server application written in PHP was not that good in terms of throughput. I had worked on database configuration and query tuning and added more additional indexes, but some calculation overhead appeared on other server. I had to install the Vanish to cache the static data, and some other issues was appeared on the other server, etc., etc. But I don't know, as your service is growing, there will be much more complex issues, I guess. For your services quality, we need to separate some services. Imagine some of the data analysts working on the main database, and they are making overhead by issuing heavy query load. For example, for a 2-year period, they are selecting the records. Then your production service will get stuck because of the load, right? So it is recommended to separate their zone by making a duplicated database and for data analytics purpose only. And that doesn't need to have latest records, so synchronizing 1 or 2 times per day would be suffice for the moment. So now, let's say database divided into 2 parts, the production layer and the data analysis layer. There's many more, backup, logging, and monitoring. AWS offers some distinct and wonderful functionalities, such as multi-AZ infrastructure for reliability, database scaling, and auto-scaling, etc., etc. If you provision enough capacity to always handle your peak traffic load, you are wasting your money. It would be better to match compute power with demand. That's what auto-scaling from AWS lets you do, but AWS costs a lot, and as you rely on the service more and more, it costs a lot in turn, but that will reduce operational burden. That's a huge advantage. In other words, there is a productivity. In other words, speed and efficiency. There's one idiom here: simpler is better. You should start from small, but please, you should be aware of possible combination of architecture, solution, best route you can choose, so you can make a good decision. On Saturday evening, I've got a call from one of our VC about our service down we are experiencing. I wasn't aware of the fact, so I was really horrible at the time. Pingdom supports heartbeat to the service, so I can quickly be notified when the server has some problem. I can add more specific custom monitor to know its status. For example, I can add a REST API to know its status. And whenever it returns error code instead of 200 OK response code, if there's some serious exception and functionally is not fine, then I will be notified by the push notification, email, and SMS, etc., etc. The Pingdom will send me brief overview of the incidents if I need. This is one page of Pingdom. In this page, we could check the server's health status and some error count and response, the status of each service is response time as well. This is New Relic. In New Relic, we can track each component's response time easily. For example, application server database calling in middleware, checking its throughput and see the potential tuning point that appeared as bottleneck. It also shows method level stats, so it's very powerful and helpful to know about your application. But it's not just a monitor, but helps you to aggregate some queries and shows which are run most times and which are the most expensive. In other page, you can check some throw queries if you added the monitor. Unfortunately, there's no GUI-based perfect tool in Linux. But there's many awesome tools that doesn't cost usually. The extra backup is useful when you need to make a replication to add a slave node to your master for HA, high availability. Usually backup will introduce high disk write I/O, right? So doing so in busy time will not be appropriate. You need to find your right time range. So also, how long you will keep your backups is necessary in terms of preserving the disk space the server would require. It is recommended to maintain a copy of your backup in terms of, so in case of some failure in the database, in data center issue, we can react to the problem. Lastly, we should consider some performance space impact. Backup always comes with a solid recovery plan, as I said before. This is a typical recovery path when your master database is failed. But if somebody connects to database while it's being restoring, then your service will get stuck because of the, many requests is delayed as the database is busy enough for doing the, restoring the database. It's not good a situation, definitely. So if you have a replica, then the situation will be okay. If you encounter some specific issue, you don't miss it. You need to document it to follow up the issue and add a checker for a certain resource. For example, the binlog size for MySQL Server. Sometimes the database consumes large disk space unexpectedly. For the single point of failure, having the replication or multi-master architecture can be useful. Although it takes more money, it will give you a productivity and safety. We often use master-slave replication model, and designing it is fairly easy in these days, and it is reliable, fairly reliable. When there's some client-side, we have a client-side replication tools such as HAJDBC, Tungsten Replicator. With using HAJDBC, we can implement multi-write to the multiple database. As it behaves like a proxy, we can open multiple independent connection to transport the data over the network. I just wanted to bring out some modern solutions. RDS service is a part of AWS. It's a cloud-hosted database. Aurora, this is a MySQL compatible, so you can use the same driver as you used with MySQL before. But in deep level, my ISAM storage is not supported, so you need to be careful when you migrate into the Aurora. You can create MySQL replicas in their admin page. What it makes awesome is that it supports the automatic failover in conjunction with other AWS solution. It will be very much powerful. So let's move to logging part. Why logging would be matter? For these reasons, logging is useful, to get the basic statistics, and it's useful for is essential for legal liability issue, right? And it's useful for some monitoring your servers. In these days, many services are worldwide level, so international startups, they are not restricted in a certain region, certain countries. But they're expanding their boundary to other countries as well. As you may heard of Google, Facebook, Spotify, Prezi, Skype, and there's many more. Also, complexity of arranging, managing the service becomes very hard. The recent trend is going small and many components is a microservice. On top of that, the number of physical sources changes constantly as we add more instances to for the growing usages over time. So the question is, how do we aggregate the logs to the central accommodation, central server? Maybe we could use some cron scripts. We could deal with some network error manually. At least we could. But imagine the number of servers is over 10, 100, 1,000. Then the situation becomes very hard. When we see them in a big picture, the solution may look like this. So if you have a problem in the batch script, then you need to look after the script. And during the time, some other failures in the other script, and we need to revisit the issue. We need to take care of two problems at the same time. That happens all the time. So without any doubt, we need a robust solution for logging. There is a famous quote in engineering world that is, don't reinvent the wheel. Everyone heard of it, right? There's some SaaS, the software as a service for logging, but that is most times that's expensive and not customizable sometimes. You might able to see the log entries, logly, etc. Maybe we could implement our own log aggregation solution using the other by adopting Kafka, RabbitMQ, ZeroMQ though. I want to introduce Flume as it's widely used in these days. It was originally used in Cloudera. For log aggregation, it's evolved to handle multiple data source, multiple streaming event data, including syslog, netcat, and Thrift, and execc. Execc is system comments output. Q could be in memory for high throughput, and 5 JDBC can be used as well. It uses transaction approach to ensure no data loss in pipeline. This is a typical topology when you use Flume for a number of servers. The separation of tier provides the redundancy, availability, load balancing, failover, and better handling of downstream failure on HDFS. Having just one node for those 4 servers wouldn't accommodate all logs. So there are 2 nodes in second tier, as you can see here. So the question is, can two Flume agents can keep up with all the load as we add more services in the first year? So the question, so when we check the official document, by rule of thumb, one aggregating agent can be used for 4 to 16 client agent. Apache Flume takes a configuration file every time it runs a task. This task is kept alive in order to listen to any changes in the source and must be terminated manually by the user. A basic configuration to read data, taking a local file system as the source and keeping channel as memory, and HDFS as sink as a data source. Fluency is very well-known solution in these days because it has many plugins, supports a more easy install by dep RPM packages. But time synchronization issue is up there because in some case, for example, syslog uses local time instead of Unix timestamp. So when it's aggregated to central server, it is becoming a problem. If we see in detail, every event has a tag in Fluency and can be used for filtering, routing. So how do we set up logging in Fluency? It's very simple, as you can see here. The logging source is specified as the tail and forward. And in the match section, we are copying them to MongoDB and Amazon S3. This is a pros and cons of Fluency. It have many plugins. Installation configuration is easier than Flume. But since it uses Ruby, there's a fragmentation issue, memory fragmentation issue, and time synchronization issue, as I said before. I want to introduce a Logstash, but Elasticsearch is used for using this Logstash. So this kind of ELK is a kind of complete solution for your log aggregation. Elasticsearch is a schemaless database, so that has powerful capability. It's easy to scale horizontally. Schemaless means that you just throw the JSON data, and it will automatically take care each field and make it index every single field. So you can search anything, it will aggregate it and group the data. Cabana is a web-based data analysis and dashboarding tool for Elasticsearch. It leverages Elasticsearch capabilities to visualize your big data in seconds. This is what Cabana looks like. A nice thing to have is you have a search box on the top, so you can put any keyword to there with wildcard symbol, for example, a Logstash star, Ruby star, specific request ID star. Logstash is written in JRuby, and it takes advantage of JVM's threading capabilities by throwing dozens of threads, so it's very fast. This is what we might see in production environment. The log will be distributed to a number of Logstash instances. For redundancy, it sends to a Redis cluster. Redis behaves like a buffer in the middle, and all logs are aggregated to Elasticsearch eventually. But there's some drawbacks I wanted to point out. Without Redis cluster, it doesn't support the persistent layer for events. For example, the message can be lost in the middle if it's not storing disk drive. Maybe some plugin has crashed and or restarted for some reason. Also, there's no message delivery guarantee, such as acknowledge things in network transmission. When error has occurred, it doesn't signal to the earlier stage in the pipeline. So some specific log data can be lost in the middle unexpectedly. If you absolutely cannot risk losing messages, make sure you investigate all the failure mode, whether the plugin you are using is implemented correctly or not. There are many components. You need to scale out the Elasticsearch engine as it grows. For HA, you need to set up Redis cluster, but that may result in too much complexity in early stage startup. I want to wrap up the logging part with these considerations. First of all, you need to care server clocks. So all clocks across your servers are synchronized equally and using same time zone. So your log timeline will be accurate across your entire environment. Also, we need to have a capability of filtering logs so you can query, analyze, visualize, and graph the data in meaningful ways. Lastly, it's important that you decide how long you retain your log. So this will affect the amount of disk space the centralized logging solution would require. Let's begin the security part. So one of the famous disputes that happen in modern development world is, do we need security at this time? If we want to deliver high quality code, then it may take more time, right? There's famous quote here. there's no finish, actually, in the security world. So you need to continuously check recent information and try to adapt it to your service when it's absolutely needed. But it's a kind of balancing with your development task, since in most startups, there's a limited resource to cover all of them. Usually, we are selectively choose our task from a bunch of to-do lists. And so some might say, why startups should care about the security? Not surprisingly, one of the first things early stage cut is security. So they are often be a preferred target for cybercrime because of lack of time, budget, and expertise to put security defenses in the right place. Attackers know this well. For a technical aspect, we may think of this kind of solution, defenses to the attacks. So here's the question: where should we start from in security topics? This could be a sort of guide for your software's security. This industry standard has achieved wide acceptance by the number of security industry and number of government organizations. It's funded by the US CERT and Meter Corporation worked on technical analysis work. This shows increasing number of vulnerabilities over the recent years. As you can see here, it's becoming more serious. The CVE provides real-world vulnerabilities, and CWE offers specific and concise definition of common software weaknesses. So what I will letting you know is based on this reference. In the following code snippet, our user's full name and credit card number is written in to a log file. So there are two problems here. First, first, the credit card number can be used to purchase something you don't know, right? Two, what if user type password into the username box? The password will be logged if you type your password where you mean to type your username. In this situation, how to log failed login attempts? First of all, we need to verify whether the username is really exists in the database or not. If it's not exist, we are not logging them. Like this, we need to care any sort of sensitive information like location, GPS coordinates, card number, as I said, social security number, etc., etc. There's a data grid for a certain database. Who do like this? Actually, I did in 2002. When I was a high school student, I did a hobby project, and I wrote them in plain text, as you can see here. Also, for transmitting the sensitive data, this kind of sensitive data over the network, let's say we are using HTTPS, TLS for security purpose. Is that 100% safe because it's been encrypted? The answer is no. There was a researcher who tried to obtain the plain text password from the TLS encrypted request, and as he figured out from a packet capture, you might be able to see the password length the user tried. So some might say, it's just password length. It's just length. Would it be matter? Absolutely. If you know the password length, you can populate all the possible combinations using letters, numbers, symbols, and special characters using the, if you use a password dictionary that containing some common used password, and if we try brute force attack, let's just say the password is not that complex, then it will be broken within a few moments, right? The article says if we know that the password is 8 characters and only contains letters and no numbers or symbol, you have a dictionary containing 200,000 password. We are able to send 10 login requests to the target website on every second. Then the password should be revealed within 5.5 hours. So it's suggesting that for any secret information being sent in browser's request, such as password and GPS coordinates and some other sensitive information, critical information, you ensure that they are padded or hashed to a fixed length to hide the actual length. We can find many tools to come up with a strong password. One of them is password meter. If you change your password, then the website will notify how much the password is strong. You should try to use lengthy password and make it complex. That is highly needed in modern computer world. 1 second. We need to measure the log rate. Whenever it's getting too high, we could conclude that it's an attack. Then we need to react to protect our servers and core system. For example, when it seems to be weird, we can throttle them to protect our servers. For a long-term plan, we need to expect some amount of delay. So each component works OK, even though some messages between servers are delayed in the middle. We need to check a list of items that need to be logged. For example, audit function startup shutdown. You know some activity logged were properly logged up to 5 days ago, let's just say. And since then, the log is disabled, but you don't know who actually disabled it because the function startup shutdown didn't log it yet. So we need to have a list for what should be logged in advance and try to maintain the document as your service evolves. Like I said, the SH1 MD5 is insecure. So if you don't change it, then it may result in the disclosure of sensitive information, critical information. So it's time to change it, I think. You need to identify the threat model, and scan for vulnerabilities and integrate security into DevOps process. But first of all, you need to know about the secure coding. As you can see here, the cost for fixing increasing exponentially as the development round goes. So the question is, how do you reduce the risk of your service being on the network? How do you reduce the risk? By minimizing a system, you are essentially removing unneeded code. By removing unneeded code, you are potentially removing unneeded risk. As for the hardening, that's taking what's left after you've minimized and running in a more secure fashion. Basically, choosing more secure defaults, so perhaps favoring more conservative security settings. Now, of course, in the world of system administration, this is both science and art. Data coming from potentially malicious users is the single most common reason of security-related incidents. For example, buffer overflow attack and SQL injection, cross-site scripting, and manipulating cookies and post-get arguments, etc., etc. So what you need to do is you need to validate all input data. Consider all input are dangerous until it's proven valid. So you should deny by default if not sure. Also, don't make any assumptions on the text encoding and environment. It often gives you a headache in many places. And you don't forget to clean the system at end of use. So you should delete the temporary files that you used before and clearing memory space when it comes to password, cryptographic keys, and session keys, etc., etc. There's a butterfly effect. So the small flaws can be a big problem unconsciously. The best practice should be encrypt the transport layer, sanitizing all input, and sign validate the messages. Lastly, we need to research some references. So here's the problem. Our string is immutable, right? So we can clear that at end of use. If we store some password or some sensitive information to there, how do we wipe out the memory space? keep the time window as short as possible in which a secret is present in the memory. If you use string, it's under the JVM, and it will be automatically collected after use. And you don't know when the GC, garbage collector, is gonna kick in. Even using like this, we use a character array to get zeroed out after use. But even using character array, it only reduces the window of opportunity to for an attacker to attack, the password. It's possible that that character array is being moved by the garbage collector, and that will leave stray copies of your sensitive data in memory. It's not always happen, but it could be. The concept of automatic garbage collection of Java is great from a developer's perspective, but and it helps avoiding many problems such as memory leak. But sometimes it has some problems like this. So we cannot manage the GC as we want. Is there anyone who can tell what's the problem you have? As a comment saying that it should clear the memory space, right? But if I use debugger to see the value, the original value test2 is still exists in the memory, even though we are trying to delete them. So basically what it does was just decreasing the count value and not the character array's actual memory space. So we can use this approach to wipe out the memory space. We are setting the length to 0, and we are overwrite the memory space with 0 value. So literally, it can be said that it gets zeroed out at end of use. I guess many of you already know about this. DNS names can be spoofed, so you can maintain a list of trusted IP address for every request. You can check the destination is trusted or not. Can you tell what's the problem here? If you see the first line, the user roles is private, right? But can be accessed from outside because it's just replaced the reference value. So when we see when you use the public method, it should copy the value to new array, as you can see here. Then if you did that, it's not accessible from outside, right? Yeah, the same problems, the similar problems here. Even though there's a thread method, we are manually adding a thread to the pool data in the last line. So we should not return the original array list, essentially. Potential attackers can use the error message that revealing operation system and OS version and product version. Attackers use this information to tune the attack against known vulnerabilities in this platform, in this version. So in many times we are provide implementation detail, such as track trace in the Java as part of its error handling mechanism. If we emit general error message and ID for tracing it later, then it would be much more safer than before. We could find many real-world examples. This Apache Drill open source project. Here, instead of diverging all the stack trace data, it just prints topmost error message followed by error ID to track it later. So it enables us to track the exceptions detail from the log file later when we need. There's some tools you may want to use for static coding, static code analysis to find those kind of vulnerabilities. I think I covered all of this, but it's not quite enough. When you're done with the implementation, you should always do code review and consult with your senior. It will give you an ability to find bug and security weaknesses, making readable code and make you deliver high quality code. At the end, you need to turn off all the dummy code for debug. So But these are basic things, but often be neglected in real world, actually. We are developing in a team, not alone. So you need to care about your coworker. What we make sure is the organization improves based on the history of security incident, and don't make the mistake again, right? And you should try to build a culture for good practices. Also, when you give feedback, your communication skill will be very much important. So instead of saying that why you didn't make a deprecate method, as you can see in the middle, in the end, we can say that would you please check this depreciation, trying more polite and communication skill. Yeah, that will be recommended. A few takeaways. I've covered all the monitoring solutions and some tips for operating multiple servers. As you have more users and more issues, and we will need a step-by-step strategy for dealing with many users and many traffic and some unexpected problem, and how do we use them in real-world situation, because the resource is limited, and we can use limited time, restricted time to implement the project. And I've covered some logging source, centralized logging source platform. I've covered some 3.3 logging centralized platform you can use. So you don't need to reinvent the wheel and just use a popular open source solution. And you will get some feedback from the community if you use them. Lastly, I've covered some security incident and secure coding, and we can identify security holes we may have in the middle, right? So I hope this will be helpful for your development work. Lastly, I want to rephrase this line again. The security is a journey, not a destination. This is the pictures references that I used before. And I think it's done. If you have a question, please feel free to ask anything. Yep.
I have a question. At the beginning of your presentation, you were showing a lot of architecture
Yep.
around MySQL
Mm-hmm.
and the replication, master, and how to cope with failure, how to copy of your data in case of data loss.
Mm-hmm.
Have you ever considered looking into solutions like Apache Cassandra?
What was the question anyway?
Have you ever looked at
Mm-hmm.
solution, NoSQL solution like Apache Cassandra?
Oh, sorry about that. Can you repeat the question again?
Yeah,
Because
so the
it's
question
not
is,
being recorded.
your original issue with data replication with MySQL and the architecture you need to create to cope with high availability and
Yep.
failure recovery. Have you looked at Apache Cassandra?
I don't have a really good answer for that because I never used the NoSQL server in my previous position. But I've heard that what I experiment was just having a multiple database in the NoSQL databases such as Redis cluster, and Cassandra seems to be useful, but I didn't really test it. The NoSQL solutions often be the suitable solution for having a multiple node, right? Mm-hmm. And if we use a MySQL server, that's traditional, one of the traditional database, it's not easy to scale out the database. That's the problem. So there's many third-party solution providers for MySQL server and Postgres and some other popular database. But I would appreciate if you can share your experience with the Cassandra 2.1 or 3. In terms of the scale out
I think it will solve your scale out issue and also data loss because when you have multiple data centers with Cassandra, even if you lose completely one data center, you can still recover from the other one. And the data replication is asynchronous, so you don't have to block, to wait for the write before replying to the client. So I think you should have a look because it will simplify your architecture.
Yeah, in this case, I don't do the managing server clusters because I'm working for another project. But if I have a chance, I will take a look about the Cassandra for some synchronize the database. Yep. Is there any other question? Do you have? No? All right, I want to appreciate your time for taking this talk. And yep, thank you very much.